here we are in task B. You guys, in task B, we're simplifying, okay? Set A focuses on addition and subtraction. Sets 2, 3, and 4 are all multiplication, okay? They want you to simplify them all and pick the one that's not equivalent. I'm not necessarily going to treat it that way, you guys. What I'm going to do is just simplify some stuff for you. So I'm going to simplify this guy. I'm going to simplify this guy. I'll simplify this one. That looks fun to simplify. I'll simplify this one. I like the B's. And then I'll simplify this one and this one. Okay. All right. So these are the ones we're going to do. Check it out. I'm going to do C first. You guys, do you see how there's a plus sign in between these two parentheses and that's it? Nothing else? That means these parentheses are actually completely meaningless, all right? You could pretend they're not even there and start combining like terms. So that's the -4 and the 10, the I and the 2I. Okay, wow, that was dark. Can you guys see anymore? No, probably not. It's fine. -4 plus 10 is 6. And I plus 2I is 3I. Done. Okay. But B, that minus sign in the middle looks so innocent. It is not, okay? You must distribute it. If there's anything other than just a plus sign before parentheses, you must distribute. So that's this. Distribute. That's all of this before these parentheses must be distributed, okay? So here I distribute that negative, so I get 3 plus 4I. Now minus 3 becomes plus 3, and negative positive 7I becomes negative 7I. Now I can combine like terms, so 3 plus 3 is 6, and then 4I minus 7I is negative 3I. Done. Okay? Let's simplify B. For B, you got to multiply out, you guys. You can do the old school way, which is my way, of just distributing. Distribute the 2, and then when you're done, distribute the negative 6I. I noticed when I did this in class, some of you really loved multiplying with the box. So you can also put 2 minus 6I and negative 3 plus 3I in the box, and the box will do this for you. You just multiply 2 times negative 3. You get negative 6. You multiply negative 6I times negative 3. You get positive 18I. You multiply 2 times 3I, you get 6I. You multiply negative 6I by positive 3I, and you get negative 18I squared. These are exactly the things you would get doing it my old school way, okay? So do whichever way you want, but you would still multiply 2 times negative 3 and get that negative 6. You'd multiply 2 times 3I and get this 6I, and you'd multiply negative 6I by negative 3 and get that 18. You get the exact same stuff, so you could see, you could do whichever way you like. Now what happens is, over here, I get 2 terms to combine. Okay, so right now I'm at negative 6, and then 6I plus 18I is 24I. And then over here, you guys, you have negative 18I squared, but I squared is really negative 1. So you have negative 18 times negative 1, which means this kind of cancels away by turning this into the opposite of whatever sign it was, okay? So now I have negative 6 plus 18, and that is 12, plus 24I, okay? If you did it in a different order, you might have 24I plus 12. while this is technically the same as that, this is wrong. Because answers involving I must always be in A plus BI form. Okay, so you cannot have the I term first, basically. You just need I all the way at the end. Okay. Now let's look at this one, this part B. Distribute, you guys, just distribute it. Boom, boom. All right, negative 2i. Oh, actually, do you see this I squared right here? That simplifies. I'm a big fan of simplifying before complicating. All right, distributing this negative 2i in here is going to complicate this situation. If I simplify this first, my complicated situations will be way easier. So remember, I squared goes away and turns this into the opposite of whatever sign it was. So now I have negative 2i times positive 4. Oh, let me rewrite it. I don't like this. Negative 2i times positive 4 plus 6i. Boop, boop. So this is negative 8i minus 12i squared. And then here we are again with I squared going away. But before it does, it turns this into the opposite sign. And then now I have 12 minus 8i. Final answer. And it's A plus BI form. Last one. Last set. You can multiply this out. You can multiply it out like this. Or you can multiply it out with the box. Okay, whatever way you do it, I'm okay with. With the box, it would look like 5i, 5 negative I. And then 5 times 5 is 25. 5 times I is 5i. 5 times negative I is negative 5i. And negative I times I is negative I squared. And then I can see that in the middle here, these two actually cancel each other out. So I'm just left with 25 minus I squared. Oh yeah, that makes sense. Do you remember when I taught you about conjugates? These are conjugates. And then now the I squared goes away, but not before first changing that guy's sign. And here's a place I can see you guys making a mistake. I can see you thinking that I squared canceled, went away, so this is now just 25. It's not, because there was an invisible 1 in front of this I squared, and that guy is still there. This is 25 plus 1, so it's 26. Part A, 26. And then 25 I squared. I'm going to do this one for you too. All you got to do is simplify it. Goes away, changes that to a plus. Don't forget that the invisible 1 right there. 25 plus 1 is 26. Done. Oh, how interesting. Doesn't 25 minus I squared? Isn't this a difference of squares? Wouldn't this factor to 5 plus I, 5 minus I, exactly what we had in part A? No wonder they're the same. Okay, moving on. Right here, we're going to rewrite some stuff. All right, we're going to rewrite this guy in factored form, which means we're going to factor it. Which means we're going to multiply A times C, put it up here. We're going to take D and put it down here. And what multiplies to 27 and at the same time adds to 26? Only 1 and 27 can do that. The bigger one is positive, so that one's going to have to be negative. And then I'm going to go to the box. 3x squared, negative 9, negative x, 27x. And now I'm going to take stuff out. 3x squared and 27x. They have in common a 3x. Negative x and negative 9 have in common a negative 1. Remember again, the negative is only because of that negative. Even if the 9 was positive, I'd still put a negative 1 there. 3x squared and x. 27x and negative 9, they have a 9 in common. Which means this guy in factored form is y equals this and this. 3x minus 1 and x plus 9. Boom, done. Now for x-intercepts, I need to take each of these and set them equal to 0. So you can add the 1, divide the 3, x equals 1/3, and here you could just subtract the 9, x equals negative 9, boom, and boom. Now, are these x-intercepts? Sort of, yeah, they are, but they're not dressed up like an x-intercept. And remember, x-intercepts like dressing up, all right? So we're going to dress them up. These are the x's. Look, clearly says so. So my x-intercepts are ordered pairs, so they need parentheses. They're going to have this 1/3. They're going to have this negative 9. And then for their y's, remember, it's 0. All right? Those are the x-intercepts in blue on top. Y-intercept. Well, that one I've actually known all along, because in standard form, the number all the way at the end is the y-intercept. We just dress it up like a y-intercept by putting that number where the y goes, and a 0 for the x this time. Okay? Now zeros, if you have found x-intercepts, you've already found zeros. Zeros are these guys. Just like as x values, like x equals 1/3 and x equals negative 9. Done. Okay, rewrite this equation in vertex form. You guys, if it's in factored form, you can either multiply it out and then put it in vertex form by completing the square, or you can just find the vertex in this form. This equation right here tells me that at 3 and at 5, I have x-intercepts. 3, right here, there's an x-intercept. There's 4, and here's 5, another x-intercept. This parabola opens up, so this is what it looks like. And where is the vertex? Well, the vertex is over here. What is this point? I mean, I don't know the y, to be totally honest, but I do know the x is 4, because that's 3 and that's 5. So I know the x of my vertex is 4. I just don't know the y. All I have to do is go to this original given equation and swap those x's out for 4's instead. Like, watch. I just say y equals 2 times, instead of x, throw it out, put 4 in. 4 minus 3, 4 minus 5, throw that x out too and put in the 4. And then you can simplify this either by typing this exactly as you see it in your calculator, or by doing 4 minus 3 is 1, but you're really supposed to be multiplying right now. And 4 minus 5 is negative 1. So 2 times 1 times a negative 1, that's negative 2. Which means this y value here is negative 2, and that looks right. Boom. Okay. So now that you know the vertex, you can write vertex form. Because vertex form is y equals a times x minus h squared plus k. And here's a right here. Here's h. And here's k. We got everybody. So vertex form is y equals 2 times x minus 4 squared minus 2. All right? Okay, what's the y-intercept of this? Man, this iPad's not going to make it, is it? The y-intercept is easy to find in standard form, which I unfortunately do not have, okay? But please remember the sign that's been on our board this whole unit, looking for an x-intercept, plug in 0 for y. Well, what do you think if I'm looking for a y-intercept? Maybe I should plug in 0 for x. Okay, so go to whichever one of these equations you like better, take the x out and put a 0 in, and then using either your calculator or your own arithmetic, solve it, all right? I always like using the equations given, because if I did make a silly mistake when I made this one, now I'm not carrying that mistake into other parts of my answer. So the given equation was 2 times x minus 3, but now x is 0. And x minus 5, but now x is 0. And again, you could type this exactly as you see it in your calculator, or you could do it. This is 2 times 0 minus 3 is negative 3, times 0 minus 5 is negative 5, and this is 30. Okay, so what's the y-intercept? It's 30, but it needs to be dressed up like 1, all right? So that means I need a 0 where the x is and a 30 where the y is, with the parentheses, the comma, everything, all right? And now it wants the zeros of this. That's something I actually knew all along. Remember, they're like almost the same as x-intercepts. That 3 and the 5, just x equals 3, x equals 5. We're done here. Now rewriting this in standard form, you guys, you just multiply it out and simplify. So we have 2 times x plus 2 times x plus 2. So the squared means x plus 2 plus 8. And now I multiply this out. So you could use the box or you could use the distributing. This is 2 times x squared plus 2x plus another 2x plus 4 plus 8 at the end. This is 2 times x squared plus 4x plus 4 plus 8. Now distribute the 2 in. So this is 2x squared plus 8x plus 8 plus another 8. So this is, oh my gosh, I've been doing this whole problem without you guys watching it. Here it is. Sorry. I distributed, got this. Then I combined the like terms in the middle, and I got this. And then I distributed this 2, and I got this. And now I'm about to add these 8s. And get this. This is standard form. Don't forget the y equals. Okay, what's the vertex? That was given to me over here. It's the opposite of this, not the opposite of this. What's the y-intercept? Well, I actually found that when I found standard form. 0, 16. And what are the zeros? How dare they? Okay, fine. Y equals 2 times x plus 2 squared plus 8. If I want zeros, throw y out and put in 0. Zeros are like x-intercepts like that. And then we just solve this by undoing or isolating x, because look, you guys, that's an uncomplicated x right there, all right? All we got to do is go through the crowd and get rid of everybody, and then we have x. So first I'm gonna reverse the PEMDAS. I do have addition and subtraction. I explained this in detail in number 1, so you can go back and look at that on this last video for task A. Subtract the 8 on both sides. Negative 8 equals 2 times x plus 2 squared. Now divide that 2. This 2, we're dividing it. We get negative 4 equals x plus 2 squared. Now we get rid of the square root both sides, get a plus or minus, and this cancels out, and it's just x plus 2 here. And now over here, square root of negative 4, that's 2i, okay? I have explained how to simplify this in detail on other parts of the videos, both of them, I believe. Now subtract the 2, and don't think you can combine these, because you cannot. Don't even think about it. Those are my zeros, all right? Notice it didn't ask for x-intercepts, because imaginary zeros means there are no x-intercepts, okay? All right, those are the zeros. There are 2 of them, negative 2 plus 2i, negative 2 minus 2i. Okay, that was task C. Let's look at task D. How did these guys screw up? All right, number 1. They wanted to use quadratic formula. Remember, quadratic formula says, but first, ax squared plus bx plus c must equal 0. Quadratic formula always comes through for us, but it's not going to do anything for us if this isn't what we start with. Okay, and this is not what these guys started with. And I'm willing to bet they didn't bother doing this. They didn't bother going minus 2, 4x squared minus 3x minus 2 equals 0. If they had, they would get that a equals 4, b equals negative 3, but that c is negative 2. Here's c in the quadratic formula, and here's their c, positive 2. That's because they took it straight from here without doing the but first, okay? That's their error. Let's go look here. Here they tried to complete the square. That's cool. So they divided the negative 14 by 2, and they got negative 7. That's great. Then they would have needed to square it, right? They need to complete the multiply the negative 7 by itself to get positive 49 and add it right here. And then also add it right here. That's what they should have done. Then this all would have factored into this. That's looking good. But look at this. Ooh-wee. Negative 50 plus 49. That's a positive. That's a negative 1. They got negative 99. That's no good. Okay, they must have subtracted that 49. They must have thought negative 7 times negative 7 is a negative 49 or something. Okay, but we'll never subtract something over here when we're completing the square. Okay, let's see what happened here. Here they decided to take this uncomplicated x, get rid of the crowd, and have x to themselves. So they subtracted the 26 from both sides, and they got negative 25. That looks good. Then they decided to square root both sides to get this. That looks good. Wait, is there always an error? Each problem has an error. Ooh, then I missed an error somewhere. 1 minus 26 is negative 25. Then they square root both sides. They have their plus or minus. This cancels. Then they get this. Oh, I see the error. Psh, silly me. Okay. This, oh my god. This is actually such a common error for you guys. Let's read it up. All right. Look what they did. They took the negative inside the radical, made it an I. Beautiful. All right. Then they square rooted the 25. and got 5. Then why is the square root still there? All right? Square roots, they don't just linger and keep square rooting your number until you're like, I don't know. It doesn't do that, okay? It's there to square root that number. And once that number does get square rooted, that square root has overstayed its welcome. It's got to go, okay? It did its job. It's time for it to go. And this guy is overstaying its welcome, all right? Square root of 25 is not square root of 5. It's just 5, all right? Now, you may say they didn't write their answer in a plus bi form, and you'd be right. That is another error, I would argue, but Desmos doesn't seem to think that's an error. They like writing it that way. I do not. So kudos if that's what you're thinking, but the bigger error is this right here. Okay. That was task D. Let's go look at task E. Determine the number of x-intercepts and explain. Oh my God. What great questions. If my test was on Tuesday and I've been asked how many x-intercepts something have this many times up to this point, saw it on the last review, saw it on the last quiz, and now here it is on this review, I would make sure I knew how to do this, okay? Let's go see. This first one, okay? This is the toughest way to tell is when they give you standard form like this. Because you can't really tell from standard form, you guys. Don't think you can. You can't. So here's what I do. I try to factor it. Because if it factors, then it has x-intercepts, okay? Let's see what can multiply to make 8. 4 times 2. At the same time, add to make 5. 8 is only 1 and 8. 2 and 4. And none of those make 5. So this actually doesn't factor. Does it mean that it doesn't have x-intercepts? No. It could still have x-intercepts. They just might be ugly x-intercepts. So I'm going to check with quadratic formula now. Okay, completing the square, I'm not doing it. I have an A, and this guy is not even, so that's definitely not happening. Quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all divided by 2a. And you guys, I don't actually care what the x-intercepts are. And because I'm lazy, I'm not going to go do all this extra work and find the x-intercepts just to tell them how many there are. I'm just going to see if there's a shortcut, an easier way for me to only find out how many. So looking at this quadratic formula, this right here is the part that tells me how many. Because if what's inside the square root, the b squared minus 4ac, if that is a positive number, I end up with plus or minus the square root of some positive number. Let's just pretend 16, okay? And that comes out nice, no I, and the plus or minus makes this 2 x-intercepts for me. But if what's inside the square root comes out to be 0, then I end up with plus or minus square root of 0. Which is just 0. And plus 0 and minus 0 are really no different. So that means that there is no plus or minus, which means that there isn't 2 answers, just 1. 1 x-intercept. Okay. But what if what's inside the square root comes out to be negative? Well, then I'll get plus or minus the square root of a negative number. Let's say negative 16, just to have a number there. Well, that ends up giving me a plus or minus something I situation. And while there are 2 zeros here, because they're imaginary, there are actually no x-intercepts. So me not wanting to do all the work, I'm just going to find out what b squared minus 4ac is, the part under the radical. A is 4, b is negative 5, c is 2, b squared is negative 5 squared minus 4 times a is 4 times c is 2. Negative 5 squared is 25 minus 4 times 4 is 16, and 16 times 2 is 32. And holy crap, look at that. 25 minus 32, I don't even need to know what it is. Just that, subtracting something bigger from something smaller, this is negative. This is so negative, which means I have no x-intercepts here. Okay? All right. Now, I did tell you guys this is the hardest one. So let's look at some easier ones. For B, all I need to do is note where the vertex is. It's at negative 3, negative 4. And I need to know which way does it open. So right after the equal sign, there's no negative, which means it opens up. So all I need to know is that this vertex is left and down, and the parabola is opening upward, which means that there are 2 x-intercepts. Now this last one, I factor, just like I wanted to do with part A, okay? I see a standard form. Remember, we can't really tell in standard form, so I factor this guy, and what do I get? I get that I need 2 numbers that multiply to make 16 and add to make 8. That's 4 and 4, both positive. So this is x plus 4 and x plus 4. That means that I've got an x-intercept at negative 4, and then another one at, oh no, also negative 4. I only have 1. Okay, this is 1 x-intercept. Why is it just 1? Because each of these parentheses could give me 1, but when they both give me the same one, that's just 1 x-intercept. All right. Number 2. Ooh, boy, do I like these questions. Let's do it. If possible, write a function with these characteristics. You guys, I'm going to write these functions in the easiest form possible because, again, I'm lazy. They want a function that has no x-intercepts and a vertex at 2, 3. Remember, the vertex and the direction are all we need. So because they gave me the vertex, I'm going to write the equation right away. It is x minus h, remember vertex form, y equals a times x minus h squared plus k. So x minus 2 plus 3. But depending on whether this opens up or down, I might have x-intercepts and I might not. So I do have to check that. If the vertex is at 2, 3, it's right up. The only way I would have no x-intercepts is if it opened upward. If it opened down, it would end up crossing the x-axis eventually. So I need it not to be negative. So this is fine. All right? If you want to be weird, throw whatever number you want there as long as it's positive. Rad 3, you could put pi, you could put 2.7, or you could just leave it alone because it's positive right now. Okay, let's move on. A function that has a positive y-intercept and a vertex at negative 4, 5. Okay, so vertex at negative 4, 5, write it. This is x minus negative 4 squared. Oh, I forgot the square up here. So sorry, you need the square or else it's not a parabola, it's a line. Plus 5. And minus minus, that's plus. So there's an equation. And then do I have a positive y-intercept? I think so. You want to know how I know? I know because if I multiply this out with all these positive numbers going on, what I multiply out will have all positives. And then if I add a 5 to it, it'll have still all positives in standard form. So that means that the ax squared plus bx plus c which is standard form, will have all positive numbers, and that's going to be the y-intercept. And so if it's positive, so is my y-intercept. Okay? If that made sense, fantastic. If it didn't make sense, just plug in a 0 for x and do the math. 0 plus 4 is 4, squared is 16, and 16 plus 5 is 21, which means the y-intercept is 21, and it's positive. Okay, a function that has zeros of 5i and negative 5i. You guys, for zeros, x-intercept form, factored form is the best. Just go x minus, and drop in the zeros. X minus 5i, x minus negative 5i. So that means that y equals x minus 5i and x plus 5i. And we don't really write functions with imaginary numbers like this. So I would then want you to multiply this all out. I'm not going to because I remember already doing this. Oh no, it's not the same. It's not the same. So close. Fine, I'll do it. Multiply it out. X times 5i, negative 5i times x, and negative 5i times positive 5i. That's x squared plus 5i minus 5i minus 25i squared. The I squared goes away, but first turns that positive. And these two knock each other out. So we have y equals x squared plus 25. Interesting. Okay. A function that has two x-intercepts, one real and one complex. Oh, I don't think that's possible. Actually, it just said a function. But you can't have this. But whatever, let's just do it. Y equals, x-intercepts are kind of like zeros, you guys. So you're going to go x minus. They want one of them to be real. So put whatever number you want there. And one of them to be complex. So put whatever complex number you want there. I just went with the easiest one I could think of, which is I. Okay. And now you multiply this out. But when you do, the i's won't go away. So I would say this is not possible. We don't give functions. We don't have imaginary functions with I in them. Okay, when you multiply this out, there's just no way you can make the I go away unless what you had to start with was conjugates, like it was here. So this is not possible. Okay, we're done. Man, I said I wouldn't do this whole thing and I freaking practically did. You're welcome. All right, you're welcome, you guys. Good luck studying. Email me if you have any questions. We'll review more on Monday. See you.